Okay, so we're doing chapter 9, problem 17. So it says we have a rocket of mass m is traveling with speed v naught along the x axis. And it suddenly shoots out fuel that is equal to 1/3 its mass. So see, shoots out fuel that is 1/3 m, perpendicular to the x-axis, and it says along the y-axis. And it says the speed of the fuel is 2v naught. Express the final velocity of the rocket in ij notation. So to do this, is we know that the momentum is going to be conserved in each dimension, such that for the x dimension, we have the initial momentum, which is just mv naught along the x direction. This is going to have to equal our final momentum along the x direction. So that our final momentum now is going to be the mass minus mass of the fuel times the initial, or times the final velocity in the x direction. And we also have the mass of the fuel, but its x component velocity is just 0 because we eject it in the y-axis only. Okay, so that's 0. So we can just do that subtraction real fast and see this is 2/3 mass v x prime, and these masses cancel such that we know that v naught is 2/3 the final x component of the velocity. Or rewriting that, we can say vx component is 3/2 v naught. Cool. So let's do the same thing in the y direction now. So for the y momentum, initially we have 0 because we just have the rocket moving in the x direction. Finally, we have the mass of the fuel times the speed of the fuel shot out in the y direction. And then we have the mass of the rocket minus the mass of the fuel times the y component. So if we plug all this in, we should see that this becomes 2/3 m v naught plus 2/3 m vy prime equals 0. So if we just want to solve this equation, we see that these 2/3 m cancel out, and we have v naught equals, or negative v naught equals vy prime. So that means we know our v vector here, our final velocity vector, is just vx prime vy prime, or in our values now are 3/2 v naught and negative v naught. So now let's put this in ijk notation as it asks, and this is the same thing as saying 3/2 v naught I hat minus v naught j hat. And this is our final velocity vector. Awesome. That's the whole problem.